Part 1, you can look at the mark scheme. Part 2, we're going to let y equal the inverse sinh of x. So the sinh of y equals x. Whenever we differentiate sinh y, we get cosh, but we've got to remember to multiply by dy dx. And whenever we differentiate x, we get 1. So dy dx equals 1 over cosh y. Now we know from our trig that sine squared plus cos squared equals 1, but we know when we are working with hyperbolic that if we are a double sign, then we have to change the sign. So that will be minus hyperbolic squared plus the hyperbolic equals 1, which means that cos squared y would equal 1 plus x squared. So when we go back over to our differential, that will be 1 over the square root of 1 plus x squared. So we have just shown that the differential of the inverse sine hyperbolic is 1 over. Part 2, we're asked to find a definition for the inverse sinh of x using logarithms. So again, we start in the same way as we did with the differential, but this time we are going to use the exponential form. So we have the following. If I multiply across by 2 and rewrite with positive exponentials, but then multiply everything by e to the y, we have a quadratic. And if we apply the quadratic formula, then e to the y equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's x plus or minus the square root of x squared plus 1. E to the y must be greater than 0, so e to the y must equal x plus the square root of x squared plus 1, so y is the natural log of x plus root x squared plus 1. So if we start by substituting, our first term becomes the natural log of 3/4 plus the square root of 1 plus 9/16 plus the natural log of x plus the square root of 1 plus x squared equals the natural log of 4/3 plus the square root of 1 plus 16 over 9. So we have that the natural log of 2 plus the natural log of x plus root 1 plus x squared equals the natural log of 3. Natural log. We're going to be subtracting, and whenever we subtract logs, we can just divide the term, so that's 3 over 2. So that gives me x plus the square root of 1 plus x squared equals 3 over 2. We now have an equation to solve, so I'm going to isolate the square root, and then that allows me to square both sides. So we have 1 plus x squared equals, square the first term, then double the product of the terms, square the last term. So 1 plus x squared equals 9/4 minus 3x plus x squared, multiplying 3 by 4. We have a 4x squared on both sides, so they will cancel. And that leaves us with 12x equals 5, which means that x equals 5/12.